on the reliability prediction, and this is a very small topic we can say in the whole reliability engineering, and it is a very important topic. So what I will do, I will go through this topic to cover a very basic aspects, that why we need to perform the reliability prediction analysis, what would be its means benefits when we will be doing the reliability prediction, and how it should be performed on any kind of industrial applications. So it is mainly on the whatever the methods are available and how the industry is taking into the consideration of reliability prediction and its data, and how they are making the decisions based on the reliability prediction. Now, the research in the development of these prediction models, and then what is the means further development in the specific modules and all, this is not the part of this presentation. So it is, I'm mainly concerned here only on that, how to apply the existing prediction approaches on the industrial on a particular industry systems. Okay. So my this is about myself. I think it is already covered all the parts of it. Okay, so just I want to highlight specifically on the implementation of these prediction approaches where I have applied in the various projects. So if you will start here mainly on the railway projects, if you will see, it is in the first line of the few these projects, EMU, DMU, it is mainly on the Perth, Shanghai Line 15, these are the Chinese metros, and then this is the again in the French metro, then Dubai and Lucknow metro. So on all these metros, this specific analysis, the reliability prediction, I have performed almost on all the metro systems. This analysis was also performed on the one of the DMRCL project on the tunnel ventilation SCADA system. And I also use the reliability prediction for the Mahindra Reva on one of its electric vehicle while performing this ISO, applying the ISO 26262. Then others, that small projects, approximately around 10 projects, I applied the same approaches, because many small industries, they were once they were completing their complete architecture, they wanted to know that what is their MTBF numbers. And for that purpose, I applied this reliability prediction for them as well. So let me go to the content which we will be going to see over here. So mainly it is on the what is the prediction and what are the benefits of applying the reliability predictions. Then next would be that how to carry out the reliability prediction at the component level and at the system level, and what are the different standards and the data sources are available for the reliability prediction. And what we'll do, we'll just quickly see the one example from the MIL 217, and we'll also see that how the various databases like NPRD, they are collecting and producing the data, and how that can be used during the reliability prediction calculation. Then one more topic that is specifically that is also studied with the reliability prediction. Immediately just after the reliability prediction, once we will do the calculation, then we'll also see that derating analysis. So this briefly one topic also I will introduce, and all will be covered from the basic application perspective. So coming to the our topic, that what is the reliability prediction? So it is the process of, can see, quantitative assessment. It's mainly we are assessing the quantitative values of a product right at its design or development stage prior to its fabrication, manufacturing, assembly, or the field operation. So main point here is that this quantitative assessment need to be performed at the design stage and before going for any kind of fabrication or any manufacturing, or we can say that putting an order for the component. At that stage, this particular analysis need to be performed. And it serves as a quantitative guide to work on several alternative designs. And based on that, what will happen once we know that what is the quantitative values will be achieved or we will get for a particular design. Based on that, we can work on the several alternative designs, that for which designs we need to put in more effort, okay, or which design will be the best suitable for a particular kind of application. So that it will help us to decide or to work, give the flexibility to work on the different designs. So if you will see, hope this particular concept of bottom curve, it has already been introduced. Okay, so wherein we can see that in a ideal environment, we will have the three different regions for a particular component or the system's operation with respect to time. So with respect to time, it is having the one phase that is known as the infant mortality, another phase random failure, and third phase is the wear out failure. Okay, and this particular bathtub curve, it is the ideal curve, and it may not be, it may be possible that for few of the system that it is only the infant mortality, and then suddenly you will end up in the wear out phase region. So maybe possible that this random failure region may not exist. And many of the electronics parts and component, this wear out failure regions will not exist, because in many cases it will be the kind of flat curve. So there are a lot of if you go through the literature, there are several justifications are given, and for each and every part and component there are different kind of bathtub curves we can get. But this is the one ideal curve for the academic point of view to understand that, to understand the behavior of the system. Okay. So what exactly the reliability prediction we will do? In the reliability prediction, there are assumptions. These assumptions will tell us that this particular infant mortality period, this has been removed. Okay, removed means it is the particular part or the component is out of this infant mortality period, and it will be operating under the random failure reason. So this is the most of the electronics, the reliability prediction standard, they will talk about like that. Okay. And if you see the mechanical part and component, then they will have the different stresses, and they will, that will be, we will come into those models as well. Okay. So so here what is happening, most of the standard, they will address the what will be the failure rate in this particular region, that is known as the useful life region. So we will get the failure rate in this particular region. So once this infant mortality regions has been removed, or this can arise due to the manufacturing defects or any quality related issues. If these parts and components are removed, okay, and then if we know the failure rate specifically in this region, then we can perform the several type of calculation that will come into the next few in the next slides. So the objective of reliability prediction is to determine if the equipment design will have the ability to perform its required functions for the duration for a specified mission profile. So generally what happens during the very initial phase of the project, okay, so this prediction analysis will be performed, and all the mission profile related information will be inserted into those models. So for example, let's say product supposed to be operated, let's say in the Dubai environment. So where we know that there is a temperature will in a particular time period, it will hit to 50 and more than 50. And then accordingly, the temperature which is actually seen by the component when it is operating at a particular place, its temperature will be very high, hitting more than 70 or above 70 degrees centigrade. So we can take into all those temperature rise information. In certain cases, what happen? The component will be continuously operating. Okay, so in that case, it will have a completely different mission profile. So, for example, when I was working with the Perth metros, so we had a specific requirement from the client that he want the system to operate continuously. It means that they are saying that they generally do not switch off the trains during the night time. They will run the trains whole day. They will just go and put the train in the depot, and they will not switch off. So in that case, many of the electronics parts and component, okay, they will be continuously working. So in that case, it's complete mission profile is different. So all those impact of those mission profile parameters, including the temperature, use conditions, those can be taken into the consideration during the initial stage of the product development, and then for how long the system is supposed to work. So that kind of information we can gather if we know the by using this reliability prediction approaches. Okay. So we'll move to the next. So this is the specific, we can say that the different phases which I have taken from the EN 50126, and this particular standard is used in the railway application. So in fact, the industries, just one point to highlight you, that industries, they work mostly on the standard based approach. Means they will follow the specific standards. Okay, and if let's say they are following a standard, and they will say that this particular analysis has been performed as per the latest version of the so and so standard. So then all the regulatory authorities, those are operating from the either safety, reliability perspective, they will consider this as a valid proof, and then those designs will be accepted as per the regulations involved in a specific country or a specific requirement. And therefore, they will work always on the standard-based approach. And this EN 50126 is one of the standard for the railway applications, specifically for how to take into consideration of REMS in the railway systems. Okay. Now, what will happen exactly as per this standard? This is the system will be divided into the different phases. So you can see this is the tender phase from the point 1 to 5. Then there will be a design phase will come, and after that there will be the operation phase. So what will happen during the tender phase? So during the tender phase, there will be the concept, system definition, and then the safety analysis and REMS analysis will be performed. Now, there are the two different types of, you can say, the contracts. They will exist. One is that it is a contract-based approach. Contract-based means, let's say, there is a specific customer. He is having the specific requirement, and then he will place the order. Okay, and then he will float the tender, and then all the suppliers, they will participate in the tender, and then they will comply their specific requirement. This is the one way. And another way is that there is a R&D based approach. For example, if you will see the nowadays, we'll take example from the cars. Okay, so cars, they are exactly going on the R&D based approach, where they will do their own R&D. They will come better than they will come with a better specification compared to the competitor, and then based on that they will advertise and they will sell the product. So their customers will be decided once they will release the product. But here in this case, it is based on the tender phase approach. So we are talking about here on the tender phase approach. Okay, so during the tender phase, before responding to the call for the tender, supplier has to perform feasibility analysis, commercial risk analysis, response to the tender, and then negotiation. So these are the part of the entering into any of the kind of tender phase for a particular supplier. For the big supplier, when I'm talking, suppliers like the Alstom, maybe that Siemens and all, when they will be going for this kind of bigger contracts. Okay, so like to supply a particular, say, train sets of 50 sets for particular cities and all. So they will go on the kind of tender phase. So during the tender phase, what they will do in the tender, there is a specific requirement will be mentioned by the client that you should have so and so MTBF, mean time between failure, or you will have so and so MKBF, mean kilometer between failure. So this kind of specific requirement will be mentioned in a 1 line items in the tender. So then what the manufacturer or the supplier, they will do, they will go for first of all on the feasibility study, whether is it feasible, that whether we can supply with all the equipment, parts and equipment meeting those kind of specific requirement. Okay, and if let's say they are going ahead with the particular tender, then what is the risk analysis? For example, they may be playing at a only that specific values, let's say 1000 kilometer, and they are based on their best approaches, best technologies. If they are using, they are able to reach to the only 1000 kilometer as an MKBF. So what is the risk involved into it? Let's say tomorrow, if they are not able to demonstrate the same target based on the field data, then what will be the risk? And this risk will be in terms of the penalties which will be imposed on a particular manufacturer. Okay, so whether it will be the direct penalty in terms of the money which he has to manufacturer has to give back to the client, or it could be the indirect kind of penalty. So indirect penalty means, let's say the customer will immediately say that, okay, if you are not able to meet the target, then your warranty will be extended by the 1 month, and we will keep on extending by 1 month till you meet the targets. So this is kind of indirect way of putting the penalties. Okay, so wherein he has to continuously keep on giving the warranty till he is able to demonstrate his what was the requirement. Then the response to the tender will happen, and then the negotiation will happen. So this is typically the process. It will be followed in this kind of big tendering process. And I myself was part of the various this kind of analysis as well, because I myself has participated in the Compass in the Singapore, specifically during the negotiation phase, because at that time there was a specific requirement, and the requirements were very stringent, and those were difficult to, we can say not difficult, but however, it was not known that what could be the possible solution we can implement. And in that case also, we can have a specific discussion with the client itself, and then we can find out the possible ways, if it is possible. If it is not possible, then whether there will be the relaxation from the client side in certain cases. If it is not that, then based on the risk analysis, whether it is feasible to go for the tender or not. So this kind of typically analysis will be done. So what will happen in this whole process? There is a very, very important role for the reliability prediction, because we should have the prediction data to perform all this analysis. Okay, so that's why, just to highlight the one specific part, that we need a reliability prediction, because we have to go for the tender, and tender is to win for the tender. This specific risk analysis, commercial cost factor, everything need to be calculated, because at the later stage, it will have a very huge impact. Let's say if customer is increasing the warranty by 1 month, or every 1 month till we will meet the reliability target. So warranty extension of 1 month means what? The manufacturer has to maintain all those resources at a particular depot. He has to keep on supplying the specific part to a particular metro system, and maybe that at that time 100 trains might be running, and therefore those kind of decisions are very, very critical at the initial phase. So after receiving offers, the customer evaluate the document and choose the best offer among them. So this is the one typical process followed, and here in this process, the reliability prediction play a very major role over here. And these are the typical terms which are used, on which I can say that these are the various terms which I have seen in the various tenders. Okay, it is even for the smaller systems, for the railway systems, and for the other systems where I worked. So these are the typically terms. For example, MTBF, mean time between failure, or we can say failure per million hour, FTMH, or mean kilometer between failure, or mean distance between the service affecting failure, and mean distance between the failures. So these are the various terms will be used. And here there is a specific difference between this MKBF and service affecting failure. So mean kilometer between failures can be simply you can run the, let's say, particular system. It is a car, or let's say train, and simply measure the kilometer and then count the total number of failures. Okay, this is the one thing. And this is the service affecting failures. It means the failures which will have the impact directly on the service. So it is a delay to the service. Let's say the service is delayed by 5 minutes, service is delayed by the 30 minutes, and then accordingly this kind of calculation will be done, and they will give the specific targets against these values. Okay, so this is the one way to do the calculation. For example, MDBF, mean distance between failure. Okay, and this here, when I'm representing C, it is a different failure type or failure categories. Failure categories means, let's say, there is a certain failures which will result into the delay to the service, specifically in the railway application. Let's say it is to the 1 minute or to the 5 minute, or maybe that some kind of failures which will delay more than 30 minutes, or maybe that more than 1 hour, and so on. And therefore, for each category, there is a specific targets are given. This is specifically in the railway application, but in other applications, it could be the different. It could be the one measurement only, that mean distance between the failure or mean time between the failure. It depends on that what kind of measurements are we are taking into the consideration, or what is applicable to that particular system. So in this case, what is happening here? It is we have to do the summation of the kilometers. Kilometers means, let's say, assume that it is a total number of train sets. So we have to count all those kilometers traveled by the trains and divided by the total service affecting failures. Okay, and then we can go get the mean distance between the failures. This is the one matrix, and these are the typically target values that will be given in the particular contract. For example, let's say it will be considered as a minor, wherein any failure on the particular system that will result in a delay to the service that is less than 2 minutes. And against that, there is a target of 6,500 kilometers, considering all the trains in a specific time period. So a specific time period means you can take the data either on the 6-month basis or 1-year basis. It will be specified in a particular contract that data will be considered on the 6-month basis or rolling window of 6 months. Okay, so when you are moving to the 7th month, so we have to consider the 7th month and last 5 months, so that it will be total 6-month data. then major failure category and the significant failure category. So there will be a different kind of failure categories we will have. Okay, and then there will be the target against that. So this is the one way that they will specify the direct target. Another way which I have seen is the target is in terms of FPMK, that is a failure per million kilometer. Okay, so for example, there will be the total trains we have, let's say 40, and total distance traveled by the train in a year is 150,000 kilometer. And these are as per the design and as per the requirement from the client. In the ideal cases that they will ask a particular train to run in a year, they will give this kind of kilometer requirement. So it could be the based on the train speed, based on the total number of stations, or it depends on client to client. So here they are given the target that train will be running 150,000 kilometer in a year. Okay, total trains are, we have the 40 trains, and next thing is that total allowed failures are 12 in a 6-month window. So this is the one specific target, that allowed failures is 12 and you should not have the more than 12 failures. Then what will be the FPMK, how we can calculate the failure per million kilometer. So this is the simplest way, because MDBF we are calculating at the fleet level. So total distance by the traveled trains. So we can see that this is the total distance 150 in the 6 month, 150,000 divided by 2 multiplied by 40 trains, and total number of failures are allowed are 12. So we can say it is a MDBF is 250,000 kilometer, and FPMK is nothing but it is a 4 FPMK is a target value we have to achieve. Okay, on a particular kind of categories. Okay, so if let's say this specific target is given, maybe given for minor, major, or significant. Okay, then accordingly what we need to do, we have to analyze the whole system. Okay, find out the failure rate of each and every parts and component, and then we have to analyze the impact of that particular failure, whether the impact will be the significant means delay greater than 5 minutes will occur or not. Okay, and then accordingly we have to count the impact of that failure in a specific category. Okay, and then we have to sum up specifically all those category and to see whether we are able to meet the targets which are given under the specific category. Okay, now the question is that why prediction and what are the benefits? So we will go specifically in one by one. So we know that the reliability prediction that will support many analyses. One is to assess whether reliability goals can be achieved. One is intrinsic reliability requirement and functional reliability requirement. So there could be two different ways the industries talk about the reliability targets. Intrinsic reliability requirement means it is the overall reliability requirements. Okay, so it may be, let's say in the railway system, if let's say one side of light, okay, in one particular car, if let's say that will fail, so whether it will lead to the impact on the function. For example, let's say we need to withdraw the train from the service. If it is not the case, then yes, it is a part of the intrinsic reliability. We have to take into the consideration of all the equipments, their reliability. Okay, however, on the functional part, they will specifically ask for a particular function, what will be our reliability targets. Okay, so here functional reliability, let's say in application of emergency brake. Okay, so there will be one specific target will be there. Okay, in the similar way, let's say for the giving the acceleration to the train, there is there are various subsystems and there are various functions associated with the combination of various subsystems, and then accordingly the functional targets are will be defined for a particular system. Okay, so we will assess intrinsic reliability values as well as the functional reliability targets. Okay, then identify the potential design weakness and compare the alternative design. So this is the another way that we can compare between the various design alternatives. Okay, and then at the same time meeting the target values, as well as we can go for the optimization, that we should have the lower cost, okay, in the design and manufacturing, and the lower cost during the manufacturing means during the maintenance. So the designs we have to select which will have the we will meet the targets, and at the same time we should not exactly put the design all the various designs in such a way so that it will again impact our the maintenance during the maintenance phase. Update the estimation changing according to design and reduce time and cost of redesign. And therefore this reliability prediction will help us that if we have the ideas from the day one that if we will make a particular design, then we will be able to meet the target. So then there is again no need to go for the redesign if we are able to predict at the initial stage of product development. Apart from that, what will happen in this prediction analysis that will help us to provide the various reliability availability analysis, establish the objective for the reliability test, track the reliability improvement, that how the reliability improvement has been taken place from one design to next design and next designs and so on. And then spare part analysis. Okay, so spare part analysis is again very important topic for going for any kind of we can say the project. Because what happened in the industries, let's say we have a specific target which is coming as per the contract, and based on that target, all the manufacturer, what they will do, they will perform the reliability prediction at their own level. Okay, if the design is their own, and at the same time they will ask a particular reliability target to their own supplier. Okay, so if this particular target values are floated down to the specific supplier, and if suppliers is getting agreed, he will say that yes, I will meet the reliability target. Okay, but if at the same time he is not showing that how many spare, means what will be the life cycle cost analysis, because he can meet the target with the multiple strategies. He can maybe use lot of redundancies. Okay, so when the redundancy will increase, this is going to be more painful at the later stage during the when the number of spares need to be managed, because its maintenance will be more costly. So at the same time, when I was also working at this in those projects, we used to directly ask to the supplier immediately that when you are have to meet the target, but at the same time provide your LCC calculation as well, life cycle cost analysis, and then total number of spares which we need for the, let's say, given duration of the project is 30 years. So in the 30 years, how many specific parts repair and replacement are overall are required, and then what will be the LCC, and that will help us to select between the alternatives of the supplier. Because at the manufacturer level, this is again very important that you have to consider that not only the reliability prediction meeting the target, but at the same time it should not happen that you are again putting the burden in the maintenance. Okay, so this specific analysis will be asking to all the suppliers as well, and at the same time all the suppliers, they will be performing their own reliability prediction. This will also help in the FMEC analysis for the finding out the failure mode, effect and criticality analysis. Okay, and again faulty analysis, warranty analysis, demonstration plans, LCC lifecycle cost analysis, logistic studies. So the prediction data, once it is there, it will help us to completely analyze the whole system. Okay. So now the question is that how to carry out the reliability prediction at component in the system level. So the best approach for any kind of reliability prediction is to capitalize on the field data. This is the one of the best approach. Okay, that we use the data from the field. Now, how we can use the data from the field? Let's say the various various manufacturer. So what they have their own implemented ERP kind of systems. So wherein they are continuously collecting the data from the field. They have the better FRECAS system developed. FRECAS means failure reporting analysis and corrective action system. So nowadays, all the reporting of a particular component failure from the field, which is operating in the various places, they will be keep on continuously gathering this data, and they will have a specific RAMS engineer. Okay, so those will be sitting on the data. If let's say this is what I'm talking is about from the clients, which they are operating the systems in the bigger domain. But yes, many clients, they do not have this kind of methods to collect the data from the field and to analyze it, and then again to use that data for the new projects and new bidding and for the R&D. So many of they may not be having this one, but yes, I have seen that many of the clients, they are following this particular process of FRECAS, failure reporting analysis and corrective action system. So wherein the data will be collected directly from the field, and this data will be continuously analyzed, and whenever the decisions will be made, or let's say new project tender, they will be going for the new project, responding to the particular tender, and then if similar kind of component, same module, if it is will be used in a new this particular system, then immediately the data will be taken, will be relooked into the from the field, that what kind of performance we have from this unit, and whether this data is helping us to take the decision, okay, whether we can go ahead with a particular design with certain MTBF value. So this is the one of the way to take the data directly from the field and use this data to take the decision for the next upcoming project. And at the same time, when this particular forecast process are defined, then that this data will also help to improve upon the current design as well. If the target will not be met, let's say during the demonstration phase, then immediately based on those data, we have to analyze the data and find out where is the issues, and then immediately address those issues to meet the current reliability values. So this is the one best approach, is to use the field data. Second, data generated using the lab testing, for example, accelerated live testing in the laboratory. So this is the again another approach wherein specifically this kind of data will be reported by the specific component manufacturer. Let's say one component manufacturer, he has manufactured, let's say, particular resistor, particular kind of capacitor and all. So he can perform on that particular part this ALT analysis, and he will report that kind of the analysis which has been performed on the part in his data sheet, and that will be used by particular industry. But however, what will happen? This kind of approaches are generally very difficult for the bigger industries. For example, let's say aeroplane for the aeroplanes or for the trains and all, because generally they will be continuously keep on updating the various kind of components and various designs into it, and then for them it is very difficult to do the any kind of lab testing. Okay, so this lab testing will be possible on a very smaller set of parts and component, maybe that it is an individual parts and component. Okay, and then maybe it is again on very sophisticated kind of missions. For example, let's say in the space mission or this kind of thing, it will be properly performed. But however, in the industries which are operating in the commercial domain, for them to perform this kind of analysis very difficult, unless there is a specific part and component which is troubling so much. Okay, so I will give you one example. Hope you everyone knows that this e-loco, which is purchased by Indian Railway from the Alstom. Okay, so in the e-loco there is a specific we have this wiper system. So for the wiper systems, it was developed specifically by the Indian suppliers, and then for that the reliability targets were not met. And for that purpose, there was a specific ALT test, accelerated live testing test was performed in order to find out the various failure modes and then to improve upon that failure modes. Okay. Then experience with similar items are expert estimates. So generally they do not have the specific means we can say that proof to be proved. So they will be used in the very initial phase of the project, but later on the values need to be calculated. But however, yes, expert estimate will also help here. For example, let's say one particular site which is working on, let's say, on the particular brake system, and in the new project they will client will ask a specific kind of braking system. So they know that's from the engineers from that side that how many parts and components they will be replacing with for this kind of system, and then from the past data they have this kind of expert we can say that data and all that they will can take the decision whether it is possible to meet those targets or not. So this will also help us, I mean, to take the expert advice on a particular parts and component which are operating in the different domains, okay, or different environment, and if they will be deployed in a particular domain, whether they will meet or not. And then next is that utilizing the internationally accepted reliability databases and reliability prediction methods. So on this we will talk here specifically that what are different databases that can be used, and then various theoretical prediction models. Okay, so that can be deployed to find out the failure rate on a particular component, and that will help us to evaluate the reliability at the complete system level. Okay, so this is the another way. Herein what will happen, all these reliability databases, they will be updated by the specific organization, specific we can say the groups. So they will be keep on continuously gathering the data. They will be doing their own analysis, and then certain theoretical models they will develop. Okay, so those models can be utilized. Okay, and then we can also perform the reliability prediction at the initial phase of the particular design. So for example, let's say we have this at the component level, how we can perform the calculation. Okay, so at the component level, we have to do the calculation, let's say specific, considering the specific component and the environment under which this particular component is supposed to be operated. So it is kind of resistor, capacitor, ICs, inductors, and all several kind of components we will be having in a particular system. And for each and every part and component, there are specific models, and those models, if we will fit the data as per our requirement or as per our operational profile, okay, or as per the environment in which the particular system is supposed to be operated. So all those parameters can be tuned into those specific theoretical models, and we can get an failure rate value for a specific part and component. Okay. And once we know that component reliability, so what we can do, we can go to the subsystem reliability. Since this particular subsystem, this is the assembly with PCBs and all the mounted parts and component that will form a particular subsystem. So all those are uh, made up of individual components. So what if we know the failure rate at individual parts and component level, we can also calculate the failure rate by using the reliability prediction approaches. Either it is a series combination when we have the one particular assembly wherein all the components are connected functionally in series connections. Okay, and once we know the individual parts subsystems reliability, we can evaluate the system reliability, because at this system particular system will be made up of individual subsystems, and individual subsystem here in this case they will be either in the functionally they will be operating in the series, or maybe they will be in the parallel, or maybe the series parallel combination. And therefore in the reliability analysis, there are the approaches that how to solve the when the system is functionally connected in the series parallel, or their combination of series parallel, or that kind of complex system which cannot be broken down in the series and parallel combination. So we have the approaches, we can apply those approaches, and we can calculate the reliability at the system level. So this is the way exactly to evaluate the initial reliability. And once we know the reliability at the system level, we can easily compare with particular target values, that if we are going to use a particular set of design configuration in a particular system, whether we will be able to meet the target values or not. Okay, and that will be the major phase for us to do a lot of to work on a lot of alternatives. Let's say we are not able to meet the target. In that case, immediately relook into that either on the parallel configuration, do we need the another one more module of this kind of subsystem, or this subsystem is having very low reliability. In that case, whether we can work on individual parts and component, or maybe that this subsystem can be replaced by another subsystem which is having the better reliability. And in this way, what will happen when we'll be working on the different alternatives, it will at the end it is going to have an impact on the overall cost of the particular system. Okay, and therefore in the initial stage of the design, the predicting the reliability is very, very important. And if we have the databases, which we have the data, specific data from the field operating condition, that will be much more near to our actual prediction values. Now, how to carry out reliability prediction at component and at the system level. So you can see this is the kind of one rolling stock for the railway kind of system. So there is a multiple ways in which we can perform this kind of analysis. One is the functional approach, which is also being followed nowadays in the railway domain. That what we can do, we can find out all the functions, that is known as a FBS, functional breakdown structure. So whole train system we can break down into various functions, various major functions. Okay, then we can simply put like this kind of thing. Let's say, for example, pantograph management. Okay, so this is a pantograph management is a completely one function. Okay, so in the pantograph management, we can have the various other sub functions. For example, pantograph management will be done by the lowering of all pantograph spuriously. This is the kind of service failure effect for this particular function we can have. Current collection loss by the pantograph. This is the another function loss we can have over here. And then we can find out the impact. Let's say lowering of all the pantograph spuriously. So what will be the impact at the overall system level? Let's say all the pantograph will come down immediately. Then we will end up in the rescue situation, because we cannot run the train. So that will be again the rescue situation. Okay. And then for what we have to do here, we have to take this particular function, lowering of all the pantograph spuriously. Okay, then either we can perform the reliability block diagram over here, or we can perform the FTA, fault tree analysis. Okay, and we can perform this analysis and we can identify that what will be the value of particular the failure rate for this particular function. Okay, in the similar way we can analyze all the functions. Okay, and then based on that specific function, we can identify that under the rescue what will be the overall MKBF, mean kilometer between failure we can have, or what will be the withdrawal from the service, the MKBF we can have, or delay greater than 5 minutes. And then we can compare these values with our target values, whether we are able to reach those target values or not. Okay, but however, here what will happen, since we know that reliability engineering is a will be the supporting to the core engineering. Okay, so it will help us to perform the analysis, it will help us to identify the failure rate. But however, it is again, we have to immediately sit with the designer, okay, and to work on to improve this particular failure rate. And there it is a main, the core engineering will come into the place. For example, to work on the better quality parts and component, whether to improve the particular function, then how it should be done through the design. Okay, so then based on that, this will help us to identify the where is the weakness in the design, and then where we have to put more effort from the design point of view to improve upon, so that we can meet the our target values. So this is the example. It is given from the considering the reliability block diagram approach. So you can see that pantograph management. So it is a spurious lowering of Pento 1 and Pento 2. Okay, so both are working as a parallel here. So if let's say one Pento will get lowered, no problem, we can still manage the function. And then we have to again put it see that spurious lowering of pantograph 1 will have the other subsystem which are working exactly to achieve this particular function. For example, Pento order circuit breaker failure, software command failure, Pento res CB trips, pneumatic switch failure, relay failure, Pento failure. Okay, so these are the various kind of architecture. Based on the architecture, we have to develop this reliability block diagram to identify that how they are functionally connected. Now here, where the reliability prediction will come into the picture. The reliability prediction will come into the picture. For example, let's say Pento res CB circuit breaker trips. So now what is the failure rate for the circuit breaker to trip? What is the failure rate for the pneumatic switch failure? What is the relay failure? If we know these values from these places, immediately we can put in this particular configuration reliability block diagram. If we know the values of whole this block diagram, we can also know the spurious lowering of Pento 1, and then we can put we can find out for the Pento 2 as well. We can solve this parallel configuration, and we can know the failure rate of this particular function, and then we can put over here whether it is falling under the rescue or it is falling under which failure classification, and to meet so that we can calculate our overall target whether we are able to meet or not. And this is the place where the further analysis from the design perspective will be carried out, whether we need to, let's say, to replace the switch, or we want another switch in some kind of parallel configuration. Okay, or what kind of design we should have so that its overall failure rate will be improved, so that to our target here we will be able will be such that so that when we will sum it up, we will be able to meet the target which are coming under the rescue scenarios. Okay, and this is the kind of rolling stock reliability prediction based on the subsystem wise. So earlier, what I have shown you here, it is a kind of function wise. So we can break down the system in the FBS, functional breakdown structure, and for each and every function we can perform, and then we can classify under the various categories, because we will be having this kind of targets. Another one is that from the intrinsic failure point of view, okay, and as well as the service affecting failure point of view. So what we have to do, we have to look into the system breakdown structure. It is from the hardware component point of view. For each and every part and component, what we can do, we can calculate the failure rate, and then we will sum up all those failures rate which will have a service affecting failure. And this is the another way to calculate is that wherein they are giving the complete whole failure rate, where service affecting failures we have separated out. So based on the hardware wise as well, we can perform this kind of analysis using the reliability prediction, and we can again, when we will be doing the summation, we will come to know that it is 114,000 MDBASF, and if let's say our target is, let's say, 100,000 kilometer. okay, then we'll be able to meet those target values. Okay, so this is the way to calculate initially to go for a particular kind of tender. And you may be knowing that in the Lucknow Metro and Kochi metros, we have the target of 100,000 kilometers as a MDPSF, mean distance between the service of technique failure. So in these cases, this will help us, okay, to take the decision whether it is feasible for the particular manufacturer, okay, to go ahead this kind of tender or not. Okay, so now we will come to various standards and the data sources for the reliability prediction. So let me know if we can take a 10-minute break or I can continue. Yes. Can continue. So we can continue or we can take some 10-minute break.
Hello.
Yes, yes.
Sir, 10 minutes break will be fine.
Okay, then yeah, maybe that we can start after the 10-minute and hope that you are aware about at least some part on the reliability, so that if anyone of you are aware on the this reliability, have you heard about this reliability terms and all?
Yes, sir, we have heard these terms. MTBF and all, we are aware of these terms, sir.
Okay, okay. And any you have given the projects to any of the students maybe in the to see its application?
Sir, partly we have actually not touched reliability with these terms, but yes, for any projects, we actually tell them to, test the system and find if they are reliable or not. But we have actually not used these terms.
So reliable means it means I understand that you might have done the kind of qualification kind of testing, whether the system is working or not, right?
Right, sir.
And probably might be that this quantification might have not been done, right?
Sir, at the component level, we always test. Then at the system level, we test for small projects. But we do not consider all these terms,
Okay, okay, okay. So here, what I'm talking about now, that I'm talking about that. Let's say we have a very bigger systems, and we want to do the practical application on those kind of systems. Then
Right.
how we can perform this kind of calculation? Okay, so probably that I mean. For the in the academic projects and all, probably this kind of application you might have not seen directly. Okay, so but however, maybe that in some small examples in your classes, you can take care of this kind of things.
Right, sir. Like you are talking at the tender level. You are
I mean, yes,
considering.
I'm talking. Yes, I'm talking about that. How the when we will be doing this analysis, I have not exactly gone into the actual system, because actual system everybody knows, and I hope I know that you know that actual system is made up of various electrical, electronic part and component in the various configuration to achieve the particular function. So
Right,
I'm
sir.
talking about that. Let's say there is a project, very big projects, and we have to perform the analysis. So then how to look into those things, and then kind of standards we can use to do the calculation. So that standard I will talk maybe that after about 10 minutes. Okay.
Right, sir. So like in case of component failure, we always, replace and then do it again. We do not test how many times it has failed. We do not consider all these parameters for small projects. So you are talking at a larger level. Actually.
Yes. And in fact, in the see whatever the projects, whether it is done at the smaller level, let's assume that this project is done at the smaller level. So project has a certain purpose, right? Because when you are doing the project, it means it will have applications, right? So when the particular project has an application, it means we have to see that it is a kind of system which supposed to be sold to the user. Okay.
Right.
So when particular project we are doing in the academic analysis and all, so assuming that that is a kind of system where some tomorrow the user is going to be using. Okay.
Right.
So now the case is that at the time we have to look into all those aspects, whether that how long the user can be able to use that particular object, okay, and maybe that system. Then
Right.
let's say, and tomorrow, let's say tomorrow we are operating a one small industry and selling the same particular product. So whether if it is not able to sustain or its failures are happening with a particular high rate, then tomorrow no one is going to buy that product, right?
Right, sir.
And therefore considering that aspects, that when a particular manufacturer is addressing those contract requirements from the specific requirement perspective, then how he is using this reliability prediction approaches to take the decision to go for a particular contract and then manufacture his product to meet those contract requirements. And
Right.
there it will help us, this reliability prediction value approach.
So we need to start thinking on product level instead of project level.
Yes,
Like-
definitely, because every project has an objective that tomorrow it will be a one product, right?
Yes, sir.
Because I mean, I'm new in this particular domain because I'm teaching from the last 1.5 years only in the specifically in the academic. So probably, yes, this is my thought process that yes, every project has application. And when we look from the application point of view, that user should be able to use it. Okay, then if we have this kind of thought process, that what the user will think, how the user will take the particular project, okay, product when he is buying it. Okay, then all the concept of reliability, maintainability, maintenance, everything will come to the picture over there. Because
Right.
all should be addressed for the particular product development.
Yes, sir. Right. Fine.
Okay, so
Dr. We are wanting a 10 minutes break. So we have requested the speaker.
Yeah. Sir, can we take the break for 10 minutes?
yeah, sure, sure.
Okay, sir. Thank you.
Thank you. So we will start from the 10:47 or 10:50.
So 10:50.
10:50. Okay, thank you.
Okay, thank you.